All right, then let's review some different factoring techniques that will just periodically show up, within the middle of a problem. You're just expected to know at this point how to do. Most basic factoring technique is GCF, which stands for what? Greatest common factor. It will work on an expression, doesn't matter how many terms it has, whether it's got 2, 3, 5, 10, it has the potential for a greatest common factor. So this is just a binomial, 2 terms. What do they have in common? An A and a B, so I'm factoring the GCF out. It's kind of like undoing the distributive property. So if I take an AB from A cubed B, what would be left? And then how about from 2AB squared? There we go. This is an expanded form. This is a factored form. Okay? Factored form means you're multiplying together different pieces to make up the expanded form. All right, then difference of 2 squares. This is a very specific technique. It's when 2 perfect squares are being subtracted. Okay, difference of 2 squares. Recall it goes to A plus B, A minus B. Now, sometimes this gets overlooked it doesn't just apply to perfect squares in a sense. Let me give you an example. Let's do 16. Some of you will look at that and you won't think of that as a difference of 2 perfect squares because of the power of 4 there. But what is the square root of x to the 4th? X squared. So I'm going to treat this like x squared plus 4, x squared minus 4. And then from there, notice x squared minus 4 is another difference of squares. Notice I'm leaving x squared plus 4 though. There is no sum of squares factoring technique. Okay, that is not factorable. All right, then we go to cubes. You saw these in Algebra 2. They don't show up a whole lot though, so it's really easy to forget these. You have difference of 2 squares. Well, in terms of cubes, you have both sum and difference of 2 cubes. Okay? A cubed and B cubed are perfect cubes, sum in between. Here's what it factors to. Does that look familiar at all? Yeah. On the difference of 2 cubes, it's same format. And we have a little acronym over there to the side that sometimes you'll have teachers use to help you remember the signs. Does anybody remember what SOAP stands for? Same, opposite, always positive, right? So same meaning this sign right here in the binomial is the same as the original. Okay, notice that down here it follows as well. This sign right here is the opposite of the original, applies down here as well. And then the last sign is always positive. Same, opposite, always positive. Questions on that? How about grouping? Grouping is a technique that only works for 4 terms. Look at those 4. Do they all have something in common? They don't have an x in common because of the constant, right? So grouping is going to be a technique that I use when maybe not all terms have something in common, but a few of them do. So I'm noticing that these front two terms, I can group them together. What do they have in common? An x squared. So I'm going to factor that x squared out, and what would it leave me with on just those two terms? Okay. Then I group the back two together. What do they have in common? A -2. If I pull that out, what's left? X plus 5. It is not a coincidence that those are the same. You need them to be the same for grouping to work, which allows me to go here. Notice what changed from this line to this line. The x squared and the -2, the two pieces that I pulled out, they come together to make this factor. And then this repeat of x plus 5, it only gets written once. Okay? Understand why that is, why it works. It's just based on foiling, the distributive property. If you were to FOIL this out, you would be taking the x squared times both of those, right? Which is what's happening here. And then you would take the -2 times both of those, which is what's happening here. Okay? So that's why these have to be the same for this technique to work. Okay? This one will pop up a ton. It's going to be a while before we get to it, but chapter 4, you'll see this a lot. Okay? All right, then we got quadratic form. Okay, quadratic form typically works on trinomials, 3 terms. Okay? I would argue that if we go back here, this example was technically considered quadratic form because I related it back to a difference of 2 squares patterns. Okay? But typically, you see it in terms of trinomials. Okay? You all know how to factor that, right? What's it go to? X minus 25, x minus 4, yes?
Yes.
All right, now notice the difference on the second trinomial. All I've done is I've changed the powers on the first term and the middle term. This can be factored very similar to what I've done up here, okay? This is considered quadratic form because that middle term, if you were to square its variable, it'll still lead you to the front term, okay? This will factor to x squared minus 25, x squared minus 4. So notice the only difference in the factorizations, now I need powers of 2 on x because this was a power of 4 here. Okay? But, now you got to watch out. This can factor more, can it? What's x squared minus 25 become? X plus 5, x minus 5. It's a difference of squares. Same thing over here. X plus 2, x minus 2. So it's always something you got to watch out for. Oh boy, the most dreaded Algebra 2 mistake, or just algebra mistake in general, I always see. When I square a binomial, so many people want to do this. They square the A, they square the B, they call it a day. What's it mean to square something? Somebody said it? Yeah, it means multiply it by itself, right? So when you write it side by side like that, you probably have a better idea of what to do. Kelsey said to FOIL. A times A is A squared. A times negative B is negative AB. Negative B times A, that's also negative AB. Negative B times negative B, positive B squared. Notice the middle two terms. They combine together. All right, so squaring binomials comes up a ton in this course and beyond, all right? So if you consistently do it this way, you're wasting your time, okay? Boiling it over and over is going to take you too long, all right? You need to learn this pattern if you haven't already. Okay, notice how the factored form here relates to the expanded form. I got to know that this is going to result in a trinomial. The first term of the trinomial is the square of this first term. The middle term is just the product of these two doubled. Why doubled? Because in the boiling process, you get the same thing twice, right? And then the last term is from this guy being squared. So apply it down here. I should know, without foiling, that this is going to become 4x squared for the first term. 2x raised to the second power is 4x squared. Then minus 12xy. If I multiply these two together, what's 2x times negative 3y? Negative 6xy. Double it takes you to negative 12xy. And then square that, positive 9y squared. Some of you are going to argue with me that it's easier to FOIL. Probably right now it is for you, but you need to learn that little format there. It'll save you some time as you move through the course.